Hello everyone, this is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about test of hypothesis for single proportion. Before going to start a test of hypothesis for single proportion, first we should know what is sample proportion. So what is the definition of sample proportion? Okay, so in a random experiment, the total number of events are n. In a random experiment, the total number of events are n and the exhaustive events are x. Then the sample proportion is denoted by p. Okay, so the sample proportion is denoted by p. So then the sample proportion p equal to, so in a random experiment, the total number of events are n and the exhaustive events are x. Okay, so then the sample proportion p equal to x by n. So this is the formula. So that is equal to number of exhaustive events divided by total number of events. P equal to number of exhaustive events divided by total number of events. So that means that is equal to x by n. So here we have example. In a manufacturing company, out of 200 goods, in a manufacturing company, out of 200 goods, 18 were defective. Then the sample proportion is, so in a manufacturing company, out of 200 goods, so here they have given that n equal to 200. In that, 18 were defective. Okay, so that means that is x value. Then the sample proportion, we know that sample proportion p equal to x by n. So that means that is 18 by 200. So like that, one more example. In a basket, there are 100 mangoes are there. In that 100, in a box, there are 100 mangoes are there. Okay, so mangoes are there. So in that 12 mangoes are faulty, are defective. Okay, are bad, are rotten mangoes. So this is here n value is 100 and rotten mangoes. Total number of mangoes are 100 and in that 12 are rotten mangoes. That means here n value is 100 and x value is 12. Okay, so what about sample proportion? So p equal to x by n. So that means that is 12 by 100. Okay, so note, population proportion is always denoted with the capital P. Generally we take p is 0.5. Okay, generally we take 0.5. That means capital P equal to always 50%. So sometimes they will not give the population proportion value. At that case, we can take P is 0.5. Okay, so next one, test of hypothesis for single proportion. Okay, so test of hypothesis for single proportion. Suppose a large sample of size small n. So here also same, what is large sample? So large sample is nothing but n is greater than or equal to 30. If n is greater than or equal to 30, then we can say that that is large sample. Okay, so suppose a large sample of size n is taken from the population, the sample proportion is small p and the population proportion is capital P. Then the test statistic z is given by, so we know that test statistic is nothing but our formula. Okay, so what is the formula here? That means what is the formula in test of hypothesis for single proportion? The formula is z equal to small p minus capital P divided by and the root of pq by n. So where q equal to 1 minus p. So where q equal to 1 minus p. So here so already I have told in single mean, no. So if we have single mean or single proportion, that means if the sample is one sample, if we have to choose one sample, that means our sample is a single sample. In that case, the confidence interval will occur. Okay, so that constant confidence interval will be there. Interval will be there. So here the confidence interval for single proportion, small p, single proportion, small proportion, that is. So the confidence intervals for small proportion or single proportion. Confidence interval for single proportion is confidence interval equal to small p minus 3 into under root of pq by n, comma small p plus 3 into under root of pq by n, small p minus 3 into under root of pq by n, comma small p plus 3 into under root of pq by n. Or we can write like this also, small p plus or minus 3 into under root of pq by n. So this is also confidence interval for single proportion. Okay, so what is confidence interval for single mean? Confidence interval for single mean. So confidence interval for single mean is x bar minus z alpha into sigma by root n, comma x bar plus z alpha into sigma by root n. Or we can write the confidence interval can also be written as x bar plus or minus z alpha into sigma by root n. So this is the test of hypothesis for single proportion. So what is the formula? Test of hypothesis for single proportion is z equal to small p minus capital P divided by under root of pq by n, where capital Q equal to 1 minus capital P. Okay, so like that, what is the confidence interval? Confidence interval is P minus 3 into under root of PQ by N, comma P plus 3 into under root of PQ by N, or we can written as P plus or minus 3 into under root of PQ by N. So that is test of hypothesis for single proportion. Okay, so first problem, a manufacturer. So here we have problems. Our first problem is, a manufacturer claimed that at least 95% of the equipment which is supplied to a factory conformed to specification, and examination of sample of 200 pairs of equipment revealed that 18 were faulty. Test his claim at 5% level. So if manufacturer claimed that 95% of the equipment, so here they have given that always percentages, if anything is there in percentages, that is nothing but population proportion. We know that population proportion is denoted with capital P. So here capital P equal to 95%. Okay, so capital P, they have given that capital P equal to 95%, and also before that one statement is there. So we will discuss about that statement later. So first, so which is supplied to a factory conformed to a specification of an examination of sample of 200 pairs. So sample of 200 pairs means here that is nothing but sample size of 200 pairs. Okay, sample size is denoted with N. So here they have given that sample size small n equal to 200. So the 200 pairs of equipment revealed that 18 were faulty. So faulty items are nothing but that is X. Okay, so test his claim at 5% level of significance. Okay, test his claim at 5% level of significance. So observe carefully, here they have given that alpha value. So alpha value is 5% level. At 5% we have to test the claim is 5% level of significance. That means alpha equal to 5% means that is alpha is 0.05. So write all the values here. Okay, so here they have given that P equal to 95%. Okay, so P equal to 95% means 0.95. So what about Q? Q is nothing but 1 minus capital P, that is 1 minus 0.95, that is 0.05. Okay, so what about N value? Here they have given that N value is 200. So what is X value? Here X value is 18. X equal to 18. So what is small p? X by N. So X is 18 and N value is 200. Okay, so that's why that is after simplification we will get small p equal to 0.09. So I have told no. So before population proportion, this is nothing but population proportion. So before population proportion and before population mean in single, so this is possible only in single sample, okay. So in single mean or single proportion, before population mean or before population proportion, one statement will be there. So if that is there, so then in alternative hypothesis, we have to take whether two-tail test or a left-tail test or right-tail test. Okay, that possibility is there in single proportion or single mean. Okay, so sometimes it will come. Okay, so it will be there. So sometimes it will not be there. Okay, so but in this question, that possibility is there. So at least 95%. At least means we know that that is greater than or equal to. So equal to, if you take equal to 0.995, that means we can take that is not equal to 95. That is two-tail test. But here I am focusing on greater than. Okay, so that is greater than means. So here I am taking p value is greater than 95. So p value is, so in the question they have given that p greater than 95. So p greater than 0.95, sorry, 0.95, 95 percentage. Okay. So and what about alpha? Alpha they have given that 5%. That means alpha value is 0.05. Okay, clear? So next one. So before going to start this problem, so what is this problem? Test of hypothesis for single proportion. So these are all large sample tests. Okay, so for large sample tests and small sample tests, so here we need to, so here we need to follow the procedure. So what is that procedure? The procedure is, so the procedure is, first we need to set up the null hypothesis, then we need to set up the alternative hypothesis, after that level of significance, after that test statistics. Here we are going to write our formula, after that conclusion. So conclusion. So in the conclusion, if modulus of z greater than z alpha, we reject. So we reject null hypothesis. In modulus of z less than z alpha, we accept null hypothesis. Okay, so that is the procedure to find these type of problems for single mean or difference of mean, single proportion or difference of proportions. So now check whether it is a large sample or not. So here they have given that n equal to 200. So what is large sample? So what is large sample? We know that large sample is nothing but if n is greater than or equal to 30, if the sample size is greater than or equal to 30, then we can say that that is large sample. So here n value is 200. So that's why that is large sample. So now let us move to the problem. So let us move to our procedure. So what is our step 1? Here we need to set up the null hypothesis. Step 1. Null hypothesis. Null hypothesis is denoted with H0. Okay. So here, what is p value? Population proportion. The population proportion is 95%. Here they have given one hint for us. So that is at least. But here I am taking that is greater than. Okay. So p is greater than 95%. P is greater than 95%. That means p is greater than 0.95. P is greater than 95% means P is greater than 0.95. Okay. So next, step 2, alternative hypothesis. What is our step 2? Our step 2 is alternative hypothesis. Alternative hypothesis is always denoted with H1. So that means, so what is alternative hypothesis? All of you know that already we have discussed in the previous 2 sessions. Okay. Not two sessions, we have already discussed in previous 3 sessions. What is alternative hypothesis? Alternative hypothesis is nothing but opposite to the, so alternative hypothesis is nothing but opposite to the null hypothesis. It is differs to the null hypothesis. Okay. So if you take greater than here, then directly you can take that is less than. So if you take not equal to, here in the null hypothesis, if you take p equal to 0.95, in the alternative hypothesis, we need to take 0.95. So if you take p greater than 0.95 in the null hypothesis, so then you need to take in the alternative hypothesis, that is p less than 0.95. So if you take p less than 0.95 in the null hypothesis, in the alternative hypothesis, we need to take P opposite, less than opposite is greater than, that is 0.95, P greater than 0.95. So if in the alternative hypothesis, P is not equal to 0.95, that means that is two-tailed test, okay. So in the alternative hypothesis, if P is less than 0.95, so P is less than 0.95, that means that is right tail test. Sorry, that is less than, no. So that's why that is left tailed test. So if in alternative hypothesis, if P greater than 0.95, that means that is right tailed test. Okay. So observe carefully our question. So in our question, they have given that. So what is our question? Our question is P greater than 0.95. So what is alternative hypothesis? According to our definition, alternative hypothesis is opposite to null hypothesis. That's why P greater than 0.95 will be P less than 0.95. So if P is less than 0.95, that means that is left-tailed test. So that is if P is less than 0.95, that is left-tailed test. Okay. So next one is step 3. Step 3 is level of significance. So here they have given that alpha value. So here alpha value is 0.05. So alpha value is 0.05 in left tail test. Alpha value is 0.05 in left tail test. So then the Z alpha will be 1.645. We have to take this value from the table. So we have to take this value from the table. So how to take this value from the table, I will show you. So how to take this value from the table, no? So here alpha value is 0.05. So alpha value is 0.05 in left tail test. So in left tail test, Z alpha is minus 1.645. Alpha is 0.05 and in left tail test, Z alpha is minus 1.645. Okay. So if alpha value is 0.05 in two tail test is Z alpha equal to 1.96. If alpha value is 0.05 in right tail test, Z alpha will be 1.645. Okay. So here alpha value 0.05 in left tail test. Alpha value 0.05 in left tail test. From the table we have to take Z alpha will be minus 1.645. So we have to take this value from the table. That means this is tabulated value. So next step 4. So step 4 is Z equal to small p. So here we need to write the formula. So what is that formula? Z equal to small p minus capital P divided by and the root of p cube by n. Okay, so we know that small p is 0.09. So small p is 0.09 and capital P is 0.95. Capital P is 0.95 and the root of capital P is 0.95 and Q is, so Q value is 0.05. Okay, so Q value is 0.05 divided by N value. So what is N value here? N value is 200. So already we have taken. So N value is 200. Okay, so substitute all these values and after simplification we will get Z equal to, so therefore Z equal to minus 55.8. Z equal to minus 55.8. So but we need mod Z, right? So that's why that will be converted to positive. Mod Z equal to 55.8. Okay. So here mod Z equal to 55.8. So now step 5. So that is our conclusion. Step 5. That is our conclusion. So here we know that mod Z alpha. So mod Z is 55.8 and what is Z alpha value? And that means the tabulated value, that is minus 1.645. Minus 1.645. So this is always 55.8 is greater than minus 1.645. So that's why mod z is also greater than z alpha. So therefore from this mod z is greater than z alpha. So that means this is a calculated value. We have calculated this value, right? So and this is a tabulated value. That means we have taken this value from the table. So that's why this is tabulated value. So here the calculated value is greater than tabulated value. Here the calculated value is greater than tabulated value. That's why we reject null hypothesis. That's why we reject our null hypothesis. That means that is H naught. Okay. So that means our given statement is wrong statement. Okay. So our statement is wrong statement. So what is our statement? The manufacturer. So a manufacturer claimed at least 95% of the equipment which is supplied to a factory conformed to a specification and examination. So this claim is wrong. Okay. So that's why that is wrong statement. So what we have taken statement now. So that is wrong statement. Now, second question. A social worker believes that fewer than 25% of couples in certain area have ever used any birth control, any form of birth control. A random sample of 120 couples were contacted. 20 of them said that they have used. Test the belief of social worker at 0.05 level of significance. So, observe the question carefully. So, a social worker believes that fewer than 25%. Always, if anything is there in percentages, we can say that that is population proportion. Proportions are in percentages. Okay, so the population proportion value is 25%. That means P value is 25%. Before that, observe carefully. Before that, one statement is there. So one word is there that is before that one word is there that is fewer than. Okay, so that means fewer than means that is less than, right? So couples in a certain area have ever used any form of birth control. A random sample of 120. Sample means here the sample size. Here n equal to 120, and 20 of them said that they have used 20 of them. That means that is X value. Okay, so here they have given that n is 120 and X is 20. And what about P value? P value is 25%. So capital P value is 25%. That means 0.25. Okay. So before that one condition is there, fewer than. That means that is less than 0.25 or less than 25%. Okay. So capital P. So capital P means population proportion is here less than 0.25. Okay, so next one is, so they have given that n value is 120 and X value is 20, but we need sample proportion. Sample proportion is denoted with small p. So small p equal to X by n. So X is 1, so X is 20 divided by n value is 120. So if you simplify this one, we will get 0.1667 like that. So 166. Okay, so R 0.167. Okay, so what about Q? So from this we can calculate Q value. P value is 0.25, right? So Q is nothing but 1 minus P. So that is 1 minus 0.25. So P value is, capital P value is 0.25, no. So 1 minus 0.25, that is 0.75. Capital Q value is 0.75. And also they have given that alpha value. Alpha value is 0.05. So fewer than, this is very, very important here. Fewer than means less than. Okay. So now we have to follow our procedure. What is our procedure? First of all, we need to find, we need to write null hypothesis, then alternative hypothesis, level of significance, test statistic, and conclusion. Okay. So first we need to set up the null hypothesis. Null hypothesis is denoted with H naught. So in the question they have given that P is population proportion, that is fewer than 25%. That means P value is less than, fewer than means P is less than 25%. That means P less than 0.25. Okay. So, and what is alternative hypothesis? Alternative hypothesis is nothing but opposite to the H1. It is denoted with H1. Alternative hypothesis is denoted with H1, and this is nothing but opposite to the null hypothesis, differs to the null hypothesis. So, if P is less than 0.5, that means differs, means P greater than 0.25. So, P less than 0.25 means here we need to take in alternative hypothesis P greater than 0.25. So, that means that is right-tailed test. So, P greater than 0.25 is right-tailed test. So, next step 3. Level of significance, alpha equal to 0.05. Okay, so we need to take alpha value in right-tailed test. Okay, so we need to take the table value. So, Z alpha value. So, this is nothing but table value. Okay, so we need to take here alpha is 0.05 in right-tailed test. In right-tailed test, Z alpha will be 1.645. Already we have discussed. Okay, I have shown in the table, right? So, Z alpha value is 1.645 in right-tailed test. So, alpha is 0.05. So, here we need to write the formula. So, our step 4 is nothing but test statistics. Test statistic means here we need to write the formula. So, Z equal to small p minus capital P divided by under root of PQ by N. So, this is our formula. So, here we need to substitute all those values. Okay. So, Z equal to small p value is, so here small p value is, already we have calculated small p value. Small p is nothing but x by n. So, that's why that is x value is 20 and n value is 120. So, from that we have to take small p is 0.167 and capital P is 0.25 and Q is 0.75 and n value is 120. So, substitute all these values here. P value is 0.167 minus capital P value is 0.25 divided by under root of capital P 0.25 into capital Q value is 0.75 divided by n. N is 120. So, after simplification, we will get this Z value is, test statistic value is minus 2.276. Okay. So, but we need mod Z. Right? So, that's why mod Z equal to 2.276. We have to convert into positive. So, that's why mod Z equal to 2.276. So, our last step is conclusion. So, mod Z equal to, we know that 2.276 and Z alpha value. So, what is Z alpha value here? Here, Z alpha value is 1.645. So, Z alpha value is 1.645. So, mod Z, so 2.276 is less than 1.645 or 2.276 is greater than 1.645. Yes, 2.276 is greater than 1.645. So, that's why modulus of Z greater than Z alpha. So, here we know that this is, we have calculated, this one we have calculated. So, that's why this is calculated value and this is, we have taken from the table. Z alpha value we have taken from the table. So, if alpha is 0.05 in right-tailed test, that will be 1.645. Okay, so that's why this is a tabulated value. So, table value or tabulated value. So, here observe carefully. So, calculated value is greater than tabulated value. Calculated value is greater than tabulated value. That means modulus of Z greater than Z alpha. So, here if modulus of Z greater than Z alpha, then we reject null hypothesis. That means, so we reject our statement. Okay, so our statement is wrong statement. Okay, so test the belief of social workers. So, the belief of social workers is at 0.05 levels. Okay, so what is the belief here? So, social worker believes that the fewer than 25% of couples in certain area have ever used any form of birth control. Okay, so what is the belief? Social worker believes that the fewer than 25% couples in certain area have ever used any form of birth control. This is the social worker belief. Okay, so that's why this belief is what he believes is wrong. Okay, so that means P less than 25% is a wrong statement. Okay, so that is our problem. Okay, so we reject null hypothesis. That means, so we reject our statement. The given statement is wrong statement. Okay, so here we are concluding that the given statement is wrong statement. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.